I will be doing problem number 1 from exam 2. Here, we have a thin-walled, hollow circular glass tube, open at both ends, with a radius of r and a length of l. It is centered at the origin, and the axis of the tube lies along the x-axis. We want to find the electric field due to the hollow tube at a point here at a distance w from the origin. So what we first want to do is consider an arbitrary slice of the cylinder that has a thickness dx and is a distance x from the center of the cylinder. So first what we need to do is find the relative position vector that points from the center of this slice to location w. So we're going to call this position vector r vector, and we're going to set that equal to, for our x value, we're going to have w minus the distance of that slice from the origin, and that will be x. So we have w minus x, and the rest of the components will be 0 because the net electric field points in this direction. That will be E net. Okay, so next what we want to find is the expression for the charge dq, which is the total charge of a single ring of the tube in terms of all the variables that were given. So we're going to call it dq equal to lambda times 2 pi r dx. Now lambda is just equal to the total charge divided by the total area, and you only deal with area if you're dealing with 3-dimensional shapes. If it was 2-dimensional, it'll be total length. So we were given that the total charge was q, and we find the total area by finding the circumference of a ring and multiplying that by the length of the tube. So you would have q over 2 pi r l. So we have dq equal to, if we plug this into dq, we have q over 2 pi r l times 2 pi r dx. Now notice I switched the little r to r because the radius of a single ring is the same as the radius of the hollow tube. So now we can reduce this, so 2 pi r's cancel out, and now you have dq equal to q over l dx. So next what we want to do is write an expression for the electric field dE made by the ring at a location w using your results from dq and the position vector. So when we write dE, we want to use the formula for the net electric field of a single ring. So we would have 1 over 4 pi epsilon naught times dq times z, which is the distance from a single slice of ring to the observation location, and we would divide that by z squared plus r squared 3 halves. So this is the equation for the electric field due to a single ring, and now we want to be able to plug in from what we had in our previous answers. So we have dE equals 1 over 4 pi epsilon naught times q over l dx, and z will just be w minus x, because the distance from the observation location to each ring changes. And we are going to divide that by W minus x squared plus r squared, 3/2. Finally, we're going to find the net electric field due to the hollow tube. So we're going to take the equation we derived earlier, which was the electric field due to a single ring, which is a slice of the hollow tube. 4 pi epsilon naught times q over L times W minus x over W minus x squared plus r squared, all to the 3/2 times dx. Now, to find the total electric field due to the hollow tube, we want to integrate this. In other words, we want to find the sum of all electric fields for all the rings. So we're going to integrate. So we will have E equals 1 over 4 pi epsilon naught times q over L. I'm just taking out these constants, and your limits will be the location of both ends of the tube. So on the left side we had the left side was at negative L over 2 because the tube was centered at the origin, and the right side will be positive L over 2. And inside the integral, you'll have W minus x over W minus x squared plus r squared, all to the 3/2 times dx. Now, using u substitution and all, we find that we're going to have q over 4 pi epsilon naught times L, and surprisingly our limits will be, because due to u substitution, your limits will change, so you will have W minus L over 2 squared plus r, and we will have W plus L over 2 squared plus r squared. I'm sorry, this would be a squared over here too. And within, we will have 1 over 2 times du over u to the 3/2. Now, continuing this, we will have q over 4 pi epsilon naught L times negative 1/2 times 1 over 2 times 1 over u to the half, with your limits being W minus L over 2 squared plus r squared, and then W plus L over 2 squared plus r squared. And these will just cancel. So now, to put this all together, we will have the electric field is equal to q over 4 pi epsilon naught L times 1 over W minus L W minus L over 2 squared plus r squared, and that will be under a square root, minus 1 over square root of W plus L over 2 squared plus r squared. And that is your net electric field due to a hollow tube.